Hello, we're looking at notes today on subtracting algebraic expressions 7-4. But before we started the notes, I just wanted to do a little bit of review with the distributive property and then talking about adding expressions. So I have these two problems up on the board that they look similar, as in I'll be using the distributive property, but one is positive, one is negative. So remember when I have the distributive property, that means I have 5 times something in parentheses. So I'm going to take that 5 and multiply it to the two terms that are inside the parentheses. A little bit. So 5 times 2x is the same thing as 10x, and 5 times positive 3 is 15. And I also have that plus sign to bring down, so I'll have 10x plus 15. Then, this is something that you did not review last year, but we have talked about this year, that when we have a negative, we are still multiplying that negative 5 to each term inside the parentheses. And there are two ways that we can look at this. You could say to yourself that I have negative 5 times negative 2x, which would be positive 10x. You can then say, okay, I'm going to bring the subtraction sign down, which means I'd be multiplying negative 5 times positive 3 to give me negative 15. What I like to do when I'm looking at this scenario, though, is instead say negative 5 times a negative 3. So I have a negative times a negative, which will give me a positive right off the bat. But as you can see, either way that I write these, when I rewrite my subtraction problem as an addition problem, I will get the same result of 10x plus 15. That is your final answer for this scenario, 10x plus 15. 10x and 15 are not like terms, so you cannot combine them together. Then to review adding expressions, we want to remind ourselves that in front of this parenthesis, there is a 1, even though we don't see it. You are not distributing the 5 to the negative 2x now because I have this addition sign that technically needs to be distributed. So if I distribute the addition sign, that doesn't change any of the values inside the parentheses. So I will have 5, and then a positive times a negative is negative 2x, and a positive times a negative again, I write negative 3. Instead of having two signs in front of a number, I just have one. It makes it a little bit easier for us to examine what we have. So this is not the final answer because I have like terms. I have two constants. I have a 5 and I have a minus 3. If I was to write this in descending order, I would start by putting my variable and coefficient. So I would have negative 2x and then 5 minus 3, which gives me a positive 2. Then for the next one, again, right here, there's really nothing except a positive 1, and because it's positive, I can just drop the parentheses. So this is the same thing as 4x plus 5. Same thing with the second set. This is really a positive 1. When I multiply both by a positive 1, I will not change the value. So it's negative 2x and negative 3. Again, my like terms would be the 4x and the minus 2x, and then the 5 and the negative 3. Those are both constants. If you want to, you could put the terms next to each other, the like terms. So I'll have 4x and the minus 2x. Then I'll bring the plus 5 and the minus 3. 4x minus 2x is positive 2x, and the 5 minus 3 is positive 2. So that was what gives me my final answer there. Okay, so I can't go any further. So looking at our notes, it states that when you subtract two algebraic expressions, you distribute the minus sign as you remove the parentheses and then combine like terms. This is similar to what we were talking about when we had the addition sign. We distribute the addition sign, but it didn't change the value. So example number 1 is asking you to rewrite each expression without parentheses. So technically, you are not distributing that 16m because there is the subtraction sign. So I'm distributing a negative 1. So I'll be distributing negative 1 to each of those terms. So this becomes 16m. I don't do anything with that. The negative 1 times 3 is negative 3. And the negative 1 times positive 8m is negative 8m. It would not be wrong to have 16m minus 3 plus negative 8m if you wanted to have that. But again, having the two signs next to each other, plus having like terms that I need to worry about, I like to just have one sign in front of the number. So they only asked you to rewrite these without the parentheses. They're not actually asking you to simplify and combine like terms. So this is your final answer. For the next one, we'll do this one together as well. There's nothing but a positive in front of that set of parentheses, and then in front of this set, there is a negative. So the first set, I can just drop the parentheses, so I have 1/3 p minus 9. Now for the next one, it's negative 1 times 1/4 p, so that's negative 1/4 p. And then a negative 1 times a negative 1 to give me a positive 1. Again, they are only asking for you to distribute the negative sign to each term. You're not necessarily simplifying. Go ahead, try the next one. This one, I think it's a little bit easier to see that you are distributing the negative 2 to each term. So the first set of parentheses, I just dropped that, and then the second one, it's negative 2 times negative 1/2, so it's half of 2, which is now positive 1, and then negative 2 times positive 4, which is negative 8h. Number 2 is asking which expressions are equivalent to 6y plus 15 minus 4 minus 8y. So the first thing that I'm going to start looking at this as is I'm going to distribute that negative sign. Just practice rewriting this to see if I can get anything different. So I have 6y plus 15, distribute that negative sign, so I have negative 4, and negative times a negative will give me positive 8y. So I look and I try to compare here, and the first choice is 6y plus 15 minus 4 minus 8y, so that doesn't work. The next one says 6y plus 15 minus 4 plus 8y, that's what I just did. And then the other two you might say, well, they're not exactly like that. But if you look at right here, where I added the negative 1, they're adding it right here as well. So that is also equivalent. And then this last one, the 6y plus 15, then plus negative 4, well, that's really the same thing as a minus 4. And minus a negative is the same thing as a plus 8y, so that one is also similar. Go ahead and try number 3. It is asking you to simplify, so you will be using the distributive property and simplifying. You are allowed to use a calculator if you would like to. Okay, so the first thing that I did was distribute this negative 2 to each term inside the parentheses. I then rewrote my statement as 3 5/10 x minus 5 4/10 minus 50 hundredths x. If you wanted to leave that 0 off, that would be fine. Then my like terms were the 3 5/10 and the minus 50 hundredths x, which will leave me with positive 3x and then minus 5 4/10. Again, that is your final answer. You had 2 different terms to start, so you should have 2 different terms at the end. Now number 4, it asks us to say what is the correct order for the steps of simplifying the expression negative 9x plus 15 minus the 2x minus 1. I think it's easier for us to just go through and actually simplify this, and then we'll decide what the correct order is. So looking over the problem, again, I see parentheses, and I need to start to eliminate those parentheses. Since I cannot combine together the negative 9x and the 15, I can drop the parentheses here because, again, there is just a positive 1 in front. So this is the same thing as negative 9x plus 15. Then for the second step, I'm going to distribute a negative 1. So negative 1 times 2x is going to give me negative 2x, and a negative times a negative, again, will give me positive 1. Then I'm going to stop and put my like terms next to each other. So I'm going to put the negative 9x and the minus 2x. Remember, when I'm bringing that term down, the sign in front of the number has to travel with it. Then I have the plus 15, and I have the plus 1. Then I will combine like terms. If you would like to rewrite the negative 9x minus 2x as an addition problem, you are more than welcome to do so. I know that negative 9 minus 2 will give me negative 11x. And then positive 15 plus 1 gives me positive 16. So looking at the order, the first thing we did was multiply by that negative sign, which is technically choice 3. And then we did the negative times the negative. We kind of did these 2 steps together, so which is choice 4. And then choice 1 was grouping our like terms next to each other, and choice 2 was our final answer. Going on to number 4, it says that 2 friends shop for fresh fruit. Jackson buys a watermelon for $7.45 and 3 pounds of cherries. Aaron buys a pineapple for $3.50 and 2 pounds of cherries. Using one variable, write expressions to represent the total amount of money each friend spent. Then write and simplify an expression to represent how much more one friend spent than the other. So they're specifically saying they only want you to use one variable. So looking at what the friends bought, Jackson bought watermelon, but they gave you it as a dollar value, and then 3 pounds of cherries. And Aaron bought pineapple, but again, they gave that as a dollar value and 2 pounds of cherries. So what we really don't know is the cherries. So I'm going to write something called a let statement, which says, let this letter be this. So let C be equal to the cherries. I'm giving that C not a value, but a description. So then we need to write our expressions for Jackson and Aaron. So Jackson, he bought watermelon for $7.45. So that sounds like $7.45 is the constant in this scenario. And then if he bought 3 pounds of cherries, wouldn't you do 3 times the number of pounds? So that's 3 times C, because we said C was the pounds of cherries. And Aaron paid $3.50 for his pineapple, so that's our constant. And then he bought 2 pounds of cherries, so that's plus 2C. Next, they want us to write and simplify an expression to represent how much more one friend spent than the other. So how much more sounds like subtraction to me. So we're going to say, take these 2 expressions. How do I know which one is the larger one? Well, if I look at Jackson bought more dollars amount, he bought a higher dollar amount, plus he bought more pounds. So I'm going to use that one first because subtraction order does matter. So I'm going to take the $7.45 plus 3C, subtract the $3.50 plus 2C. Now it is important that you do not drop those parentheses. So that's why when I first wrote my expressions, I put the parentheses right here, because that whole expression represents Jackson's purchase and that whole expression represents Aaron's purchase. So in front of Jackson, the $7.45, I can distribute a positive sign so that doesn't change anything inside the parentheses. I need to now distribute this negative sign, and I'm just putting the 1 behind there to remind myself. So this is negative $3.50 and the negative 2C. Then you can put their like terms next to each other, so I'm going to bring the 3C down and the minus 2C, and then the positive $7.45 and the negative $3.50. 3C minus 2C is just C or 1C. It doesn't matter which one you want to write that as. And then $7.45 minus $3.50 is going to be positive $3.95. So this expression represents how much more Jackson bought than Aaron. Number 5 says, write and simplify an expression for the perimeter of the large rectangle. Let's remind ourselves that perimeter means distance around an entire object. So I'm highlighting the word perimeter and highlighting the actual perimeter of that rectangle. Now when I first looked at this, I see some X's. I don't see that they even labeled how long the sides are, so I need to figure this out. From here to here, that is 2 inches. So if I carried that over, wouldn't the 2 inches also be right here? That's 2 inches. And from here to here, well, they said on the other side it was X, so that's also going to be X right here. And from here to here is 2 inches, so again, that'll be 2 inches here. So on that side, it is 2 inches plus X plus 2 inches, which is the same thing as X plus 4. Over on the bottom, they're saying that's 2 inches, so this is 2 inches. It's a different color. This is 6 inches, so this is also 6 inches. And then this again is 2 inches. Excuse me, try to use a different color here. So I get 2 inches. And again, I would add those up to all give me 10 inches. So now I know that the length and width are 10 inches and X plus 4. So I'm going to now add those all up, and we can do this two ways. I can say x plus 4 plus x plus 4 plus 10 plus 10. I can do it that way. Or I could say I need 2x plus 4s because I need 2 lengths, and I need 2 10s because I need 2 widths. So either way will get you your correct answer. So up here I have x, which is 2x, and then I have 4, 4, 10, and 10. 4 plus 4 is 8, 10 plus 10 is 20, so that will give me 2x plus 28. Or I can use over here, the distributive property will be 2x plus 8 plus 2 times 10 is 20. So again, there's my answer of 2x plus 28. So remember that perimeter formula, the P equals 2L plus 2W, that's what I'm using right here. So now they're asking us to write and simplify an expression for the area of the shaded region. So I don't want to go too far there. So to find the area of the shaded region, I need to first find the area of the large rectangle. I also need to find the area of the small rectangle. And then to find the shaded, I would need to subtract those two. So area, you can use base times height or length times width. So the area of the large rectangle would be 10 times x plus 4, which I would simplify down to 10x plus 40, and it can't go any farther than that. Then for the small rectangle, it is 6 and x to give me 6x. And then to find the shaded, it's going to be the large minus the small. So in this scenario, I'd have the 10x plus 40. If you want to put that in parentheses, you certainly can. And then minus the small would be minus 6x. And what you notice is, again, that if you have positive in front of the 10x, that just stays 10x plus 40, and that is minus 6x. So we have 10x minus 6x, which is positive 4x, and then 4x plus 40 to give us our answer of how large the shaded region is. That means that if I was to actually give you x right here, let's say x was, well, it's appropriate, probably 2 inches, I could take 2 and substitute it into my expression. All right, thanks for watching. If you have any questions, please be sure to ask.